When pulsed wave Doppler is selected, the cursor line has a movable gate. The trackball or touchpad can be moved left or right to move the cursor line left or right. The trackball or touchpad can also be moved up or down to move the gate up or down into the direct flow of the valve. If the gate is not aligned exactly with blood flow, most machines allow you to adjust the angle of the gate and calculate the actual blood flow velocity. Remember, the greater your angle of deflection, the greater the inaccuracy of the calculation. It is better to move the transducer to place the spectral Doppler cursor directly in the valvular flow. With pulsed wave Doppler, blood flow is measured only at the gate and nowhere else on the cursor line. The gate is placed in the area of maximum flow velocity. This is usually at the tips of the valve leaflets when they are fully open. Maximum flow velocity with pulsed wave Doppler is limited to 1.5 to about 4 meters per second, depending on the machine you are using. With many ultrasound machines, computer capacity is limited. The ultrasound machine's ability to perform multiple tasks simultaneously is limited. Maintaining a two-dimensional image with color flow Doppler while applying spectral Doppler may limit the measurable velocity of spectral Doppler. If you narrow the two-dimensional sector width, you will reduce the ultrasound machine's workload and free some computer capacity to apply to spectral Doppler. Remember, if you use color flow simultaneously, you are dividing available computer capacity. If you turn color flow Doppler off, more computer capacity is available to increase the pulse repetition frequency or scale for spectral Doppler. Spectral Doppler limitations are a function of transducer frequency, depth, and computer capacity. A higher frequency transducer will have lower limits of measurable flow velocity than a lower frequency transducer. For example, this 5 to 8 MHz phased array cardiac transducer begins pulsed wave spectral Doppler with an upper and lower velocity limit of about 90 centimeters per second and can be increased to 120 centimeters per second at a depth of 7.2 centimeters. If I switch to a lower frequency, 1 to 4 MHz phased array cardiac transducer, pulsed wave spectral Doppler begins at about 90 centimeters per second, but can be increased to 160 centimeters per second at a depth of 7.5 centimeters. Now, as I increase depth of the transducer and then move the pulsed wave gate to increased depth, the maximum measurable flow velocity decreases as depth of the gate increases. Most ultrasound machines have a knob or toggle to allow you to increase or decrease Doppler gain. When gain is too high, color speckling occurs in both fluid areas and tissue areas. If speckling is present, decrease Doppler gain until speckling of tissue areas disappears. To show a well-delineated waveform of a valvular insufficiency or lesion, the spectral Doppler cursor must be in the direct flow of the lesion. If the actual valvular lesion flow deviates from the cursor line, the very peak of the waveform is often washed out or a faded gray. As examples, sometimes the anterior mitral leaflet prolapses, directing the insufficiency towards the left atrial free wall. It is most accurate to place a spectral Doppler cursor in the flow from the right side long axis view. Sometimes the insufficiency goes straight through the mitral valve toward the dorsal left atrium. It is most accurate to place the spectral Doppler cursor through the middle of the mitral valve from a left apical four-chamber view. If you are seeing washout, the spectral Doppler cursor is not in the direct flow of the lesion. In some cases, it is not possible to place the cursor in the direct flow. Color flow Doppler will help you locate the flow of the lesion. If positive or negative blood flow velocity exceeds the available scale, wraparound or aliasing will occur. If the main flow is positive or up, you can move the baseline down to increase the upper scale. If the main flow is negative or down, you can move the baseline up to increase the lower scale. If flow still exceeds the available scale, you will need to increase the scale or PRF. If wraparound or aliasing is still present, you must increase the PRF. PRF is pulse repetition frequency, or the number of sound waves sent out by the transducer per second. Increasing the PRF increases the scale of measurement in spectral Doppler. By moving the baseline and increasing the PRF, you can increase the measurable blood flow velocity in pulsed wave Doppler to as much as 1.5 to 4 meters per second, depending on the ultrasound machine you have. Narrowing the ultrasound sector width and turning color flow Doppler off frees more computer capacity to apply to pulsed wave Doppler. If wraparound or aliasing still occurs, the valvular flow velocity is exceeding your measurement capability, and you need to switch to continuous wave Doppler.